we're going to go over homework F, number 6, and number 12. So number 6, we have, there we go, equal to 3. But guys, if I'm solving by factoring, it has to equal what?
0.
0. Good. So I need to subtract the 3 over here. And then I have 42x squared minus 15x minus 3 equals 0. Do you agree?
Yes.
Okay. So let me see. Guys, is there a GCF here? 42, 15, and 3?
3.
Yeah. There's a GCF of 3. So take that 3 out of there. That means we're dividing everybody by 3. And then we have, what is this, 4? Yes? Okay. So now, all right, remember, this GCF is just going to wait, right?
Yeah.
Now look inside the parentheses. And if I look at this one, guys, I have a 14 that's in front of the x squared, right?
Bring the 14 down.
Yeah, but you remember we first have to do AM because it's the trinomial.
Yeah, but you can swing it.
You got to swing it over. Yes. So what is 14 times negative 1?
Negative 14.
Negative 14, that's my new n number. What's still my a number?
Negative 1.
Huh? Negative 5. So what two numbers multiply to give me negative 14, but adds to give me negative 5? Negative 7 and 2. Good. So here's where a lot of people made mistakes on the factoring test. When you do this way,
You got to bring it in to replace it.
good. You've got to bring down the first, and you've got to bring down the last from your original expression. So your first is 14x squared, right? And then your last is minus 1. Yeah? So then you have to rewrite this minus 5x using your two numbers that you have. So minus 7x and plus 2x. Yes? All right. So then now I have 1, 2, 3, 4 terms. So I'm going to divide it in half. And let's find the GCF on the left-hand side. 14x squared minus 7x. What's my GCF there? 7 what? 7x. So if I divide, then I end up with 2x minus 1. How about on the right-hand side? What's my GCF? The only GCF I can get from this.
1.
1. Divide everything by 1, and you have 2x minus 1. Did I do this right? How do I know if I'm doing it right?
But the inside matches.
Good. My parentheses match. So I'm going to do my double parentheses.
And wait, you have to put the 7x plus 1 too.
Good. 7x plus 1 goes in the other one because it's these guys, right? Okay. And then please don't forget you had a GCF all the way in the beginning, right?
Yeah.
And don't forget, all of this was equal to 0, right?
And that's when you split it apart and then like yeah, they
Good.
So now you have to make all the little ones equal to 0.
Good.
Yeah.
Every factor gets set equal to 0. So your mini equation. So now I have 3 equals 0. I have 2x minus 1 equals 0. I have 7x plus 1 equals 0. Yeah? Hold on. 3 equals 0. Is that right? Is there even an x here that I can solve? No. So it's just throw it out. I don't need it.
Yeah.
How about this guy?
+1 on both sides.
And then divide by 2. So you have x equals 1 half.
And then you, on the next side, you subtract 1 from both sides.
Good. So then when you solve this next one,
And then you divide. And then x is -1/7.
all right? And then the last step would be to put in a solution set, which, listen, I'm not going to mark you wrong if you don't, but it's just a good habit to get into now, all right? Okay. Questions? Okay, so now let's do number 12. Number 12 says, I'm going to tell you, number 12 looks like it should be harder, but actually number 6 was a little bit harder than number 12. Number 12 is just a little messy, right? This whole thing should be equal to what?
0.
0. But it's not. We got to move everything on the right side over to the left, okay? This first thing, this first term, x squared.
You subtract that from
Yeah. Good. Subtract that out so we can get rid of it. Now what about that negative 4x?
You add that to 5x.
Yeah. Good job. So then now we have equal to 0. Let's combine like terms over here on the left side. What is 2x squared minus x squared? 2 minus 1? 1x squared, or just x squared, right? And what's 5x plus 4x? 9x. And then just bring down your minus 22. Now, I have a trinomial, so this is AM. What's my M number? Negative 22. Oh, which, by the way, there's no number here. I mean, kind of is 1, right?
You could still swing it though.
Yeah, you could still swing it, right? Do you want to swing this one? Yeah. Yeah? I mean, because it keeps it consistent. 1 times negative 22 gives me negative 22, right? What's still my A number? 9. So what two numbers multiply to give me negative 22, but adds to give me 9? 11 and negative 2. Super. Okay. So then that means bring down the first, bring down the last. Down the first, bring down the last. Rewrite the middle. So the middle term is plus 11x minus 2x. Yes? Divided in half. Let's find the GCF of both sides. X is the GCF on the left side. On the right-hand side, what's my GCF?
2.
Oh, negative. Negative. Look.
Oh yeah, bring it negative.
Yeah, negative 2. If it's starting with a negative, you've got to bring that negative down. I know I'm doing this right because my parentheses match. So double parentheses, x plus 11 goes in one, and these guys go in the other one, right? Did I have a GCF way in the beginning somewhere? No? Okay, so then this whole thing is equal to 0. Now, mini equations, right? Everybody gets set equal to 0. So x plus 11 equal to 0. X minus minus 2 equal to 0. X equals? And x equals? 2. We like to put the smaller number first. Okay? Questions? All right. So today we're going to talk about another method that we can use to solve quadratics. Okay? So when we solve an equation for x, basically what we're trying to do is we're trying to find the x-intercepts. All right? And when we solve quadratics, there will always be a solution. All right? Or solutions. You always have one or two. Solution. It could be two, though. I don't know. Just say there will be a solution, right?
Just put solution and then put x in parentheses.
Yes,
because
but
it
you
applies.
want to say a solutions, right?
Because it doesn't apply all the time.
You're right, but you know what? It's okay. Let's leave this. So here's the thing. Look at your graphs, right? Look at this first one. Guys, how many x-intercepts do you see on this first graph? 2. X-intercepts mean where does this graph cross through or touch the x-axis? Right there and right there, right? So this one has 2, and those are actual numbers, aren't they? Isn't it actually at 2 and at negative 2? So then these are real numbers, 2 real. Look at the next one, guys. There are none, right? There are no x-intercepts, but there are, right? Well, here's the thing. There are no x-intercepts, but we do have solutions. This means we have 2 imaginary solutions. Wow, now that we have imaginary numbers, anything is possible. All right, and if it's on the y-axis, that's the imaginary, okay? All right, so look at the last one here. Does it cross through the x-axis?
Yeah, 0.
Well, you know what? Does it go through it though? No. What does that do? It looks like it's just touching it, right? So these kinds of graphs where it looks like the graph is like bouncing off of the x-axis, because doesn't that look like it? It bounces off of it, right? This means that you have one real solution. Although we say one real, but if we solve this out, we're getting x equals 0 and x equals 0. You do have 2, it's just the same number, okay? So in this case, when it looks like it's just bouncing off, we say it's one real, but this is called a double root. Does that make sense? If it just bounces off, it is a double root. So what are the different names for solutions? We can call these, well, for one thing, solutions. Zeros.
X-intercepts.
X-intercepts.
That's all I got.
And one more. Starts with an R.
Radical.
No.
Real number. Roots.
And roots. Okay? So solutions, zeros, x-intercepts, and roots. I can ask you for the x-intercept, I can ask you for the root, the solutions, or the zeros. It all means the same thing, okay? So the first method to solve quadratics is solving by factoring. And we did that, right? We've already done that one. So the second method is solving by square roots, but before we can do that, we need to go back and refresh our memory on simplifying square roots, okay? So let's talk about something. Do you guys know what prime numbers are?
Prime numbers.
Yeah. Prime numbers are numbers that you can only get by multiplying itself and 1. It's the only numbers. So, okay, it depends on what textbook you're looking at, and a long time ago they used to call 1 prime, and apparently now they're not calling 1 prime. I don't know. It's crazy. But for our purpose, we're just going to say 1 is a prime. Okay? Think about 2. Is 2 a prime number? Is the only way to get 2 is to multiply 2 times 1? Yeah. Right? 2 is a prime number. How about 3? 3 times 1? That's the only way you can get 3, right?
Yeah.
Yeah, and that's a prime number. How about 4? Is the only way to get 4 4 times 1?
No, 4 is not a prime number.
It's not, because you can do 2 times 2, right?
Yeah.
4 is not a prime. How about 5?
Yes, it's a prime number.
Yeah. How about 6?
No.
No. How about 7?
Yeah.
Yeah. 8?
No.
9?
No.
No.
No. Good. That was a little tricky. 10?
No.
11? Yes.
Yeah.
12?
No.
13?
No.
Yes.
Yeah.
13 is that is a prime number. 14?
No.
15?
No.
16? 17.
Yes.
Yeah. All right, and then we can stop at 17. Okay. So the reason why I'm going over prime numbers is because when you simplify radicals, you're basically prime factoring. We're breaking down the numbers until we get them to all be prime numbers. Do you know what I mean? And you can't break it down anymore. So let's look at number 1, square root of negative 52. We learned this 2 classes ago, right, guys? If there's a negative inside the square root, what comes out? An I. If there's a negative inside the square root, the I comes out. And then now inside is just a positive 52. Yes? All right, so you got to be super organized with this, okay? I know some of you guys have done like the factor tree and the factor ladder. I'm just going to factor it under the radical, okay? Now, 52 I know is not a prime number. 52 is what times what? Well, it's even, so I know it's got to be at least divisible by 2. Try it. What's 52 divided by 2?
26.
Okay, so 2 times 26, right? Okay, I have a prime number here. I got this 2, right? Okay, I can't break that down anymore, but can I break down 26? See if you can do, yeah? All right, well then let me copy this over. I'm going to bring down that 2, right? And then you said 26 is what times what? What, 26 is what times what? 2 times 13, right? So guys, look, can I break down 2? No, it's a prime number. Can I break down this 2? No. 13? No. So I have all prime numbers, so now I'm ready to decide what stays, what goes, okay? What you're looking for when you're doing square roots is you're looking for 2 of the same number. number, okay? And if you have two of the same number, circle that, and only one of them gets to come out. So then the 2 comes out and it joins the I outside. Yeah? And then inside the square root stays whatever didn't have a partner. What's still inside the square root?
13.
13. And then there you go. Do you remember this?
Yeah, a little bit.
Good. So I'm going to show you a little calculator trick to make sure that you are doing this correctly. So just in case, say I rushed through and I was like, I don't know if I simplified that one right, but I don't want to go back and do it from the beginning. Well, square root of negative 52. Put that in your calculator, please. Square root of negative 52. Look at that weird decimal with the I at the end, right?
Yeah.
Now put in your answer, your simplified form. 2I root 13. Did you get the same thing?
Yeah.
Yeah, that's how you know that you simplified it correctly. Okay? Now, let's try the next one. Square root of 196. Guys, 196 breaks down into what times what? 2 times. Oh, I thought it was one. Okay. Sorry, Abner, you're right. So 2 times 98. Okay. By the way, how do I know that I don't need an I here?
It's not negative.
It's not negative inside. Good. All right, so the 2, I can bring that down, right? Because 2 I can't break down anymore. But how about the 98? What times what? 2 times 49. Look at that. I have 2 2s. All right, let's just keep going. Don't do the whole, circling the pairs and stuff yet. All right? But just be conscientious of which ones you need to keep bringing down. Okay? Are you writing this down? Come on. And then 49. What times what gives me 49? 7 times 7. Oh, I like that. 7 times 7. And guys, can I break down 7? No, it's a prime number. So I'm all done simplifying because I have all prime numbers. I need to find groups of 2 that are the same. Here's 1 and the 7s. So remember, when you have these groups, only one of them can come out, right? It's the representative, right? 2 comes out, and then the 7 comes out, and they multiply. Hey guys, yeah, it is 14. Do I have anything left in the radical?
No.
No, nothing left in the square root, right? So then it's just 14. And we know that the square root of 196 equals 14. That's a perfect square. But this is how we can see the breakdown. Okay? Where did that come from? All right? Now let's try number 3. Square root of negative 32. What comes out? I. Good. So it's I root 32. 32 breaks down into what times what? Huh? 2 times 16. Okay, good. 2 times 16. Which one of those can you break down more?
16.
All right. So I'm going to bring down the 2. I'm going to break down the 16 into what times what?
4 and 4.
Okay, 4 times 4.
And then out of each of those, you put 2 and 2.
Yeah, you got to break down each of those 4s.
So then you have 5 2s. Is that right?
Is that right?
I think 5 2s. So then do you only pull 1, 2 out and then group the rest? Group this?
No, how many do you need in the group?
2.
So here's a group of 2. Do you have another group of 2?
Yeah.
Yes.
All right. How many come out from each group?
1.
1.
So the 2 comes out. Then this 2 comes out. What was already out? I. What stays in?
2.
2. Don't leave it as 2 times 2 times I, okay? What is 2 times 2?
4
4. So it's 4I root 2. Are we okay with that? All right. How do we feel about this? Do you want to do another one? All right, then you guys try number 4, please. I know you guys are working independently on number 4. I'm going to put my work up and see, you know, if we're all doing it right. And, you know, we may choose different numbers, and that's fine. Just make sure we have the same simplified form, okay?
When you have all prime numbers, you just leave it as it is.
And then that's when you do the circling. Are you on number 4 right now?
Yeah.
Okay, so are you down to here? Did you get 2 times 2 times 2 times 11?
Yeah.
Okay, so now what do I circle?
The 2s.
Oh,
The 2.
the 2 2s?
Yeah.
So then one of those comes out?
Yeah.
What happens to that 2 and 11 that stay in?
You multiply them.
Good, and you get 22. Well, there you go. Did we all get that for number 4?
No.
I do.
121 root 2.
What?
I got 121 root 2.
For what?
4.
Where did you get 121? That's bigger than the number that was already in there.
I don't know what it's involved.
Yeah? Okay, that's okay.
I put 88 into 44 and 2, and then 22 and 22 and 2, and then 11 and 11 and 11 and 11 and 2.
No. But 44 is 22 and 2, not 22 and 22.
Oh.
Right? So guys, can we look at number 6 together for a second? Number 6, I have an I that comes out, right? And then I have I root 26. Guys, 26 is what times what? 2 times 13. So I, and then that's 2 times 13. Wait, are those both prime numbers? Can I get a pair? Can I get a group of 2 with the same number?
No, you take one. Well, you just multiply it, I think.
Yeah, so then you know what?
It should be
Nothing comes out
I-26.
except I. And then it just stays I root 26. Okay? Sometimes you don't have a group of 2 with the same number that can come out. So you just leave it. Alright, so number 5. Did you guys see number 5 too? Yeah, try it. Try number 5. I'll put up my work. If you use bigger numbers because 216 is such a big number, that's fine. Or you can use the smaller numbers. So you could say 2 times 108. Right? Okay, that's fine. And let's keep going with this. Right? So you guys trying it on your own. I have one group of 2's, right? And then I have two groups of 3. Right? So then 1 from each comes out. 2 times 3 times 3. Yeah? Mm-hmm.
You got 3 times 27 would be 81. So it's 2
Ah, sorry. You know what? No wonder. I was like, why is this wrong? Sorry about that. Okay. No, or did I do that on purpose? Teacher strategy. It's recording. All right. So, what do you have? What should this final answer be? Start over from right here. Huh? All right. Sorry about that. All right. So now I have group of 2's, group of 3's, and then I have a 2 and a 3 left over inside, right? Okay, I multiply those. You're right. So let's see. A 2 comes out, a 3 comes out, and then I have a 2 and a 3 inside. So that's 6 root 6. Yes? All right. Okay. So, you know what? I'm going to skip this one. Can we go to the back? I'll show you that one for our warm-up next time, okay? So here's some important notes about solving by square roots. Use this method when you can get x squared or parentheses x, minus something or plus something squared by itself. Okay?
Is that x minus or negative x?
No, x minus a number. All right? Here's the thing. It should look like this. X squared equals, or parentheses x minus or plus a number squared equals. It should not look like this. Ax squared plus bx plus c equals 0. If you have a trinomial like that with the bx term, you can't use this method. Okay? So what is the opposite of squaring? To get rid of a square, you need to square root. All right? And when you square root, when you guys draw the square root, you have to get 2 answers. You get plus or minus. You have to put plus or minus. Oh, you know what? That's on the next one. Sorry. Oh, wait. Plus or minus. If you write in the square root, then you need to have plus or minus. You know what? I don't know what this blank is for right now. I don't know what I was thinking when I was doing the notes, so we'll come back to that. I think it's like real or imaginary.
Positive and negative?
No, it's just real or imaginary. I think that's what it is. But it's okay. The most important thing is if you draw in the square root, you gotta put plus or minus. All right. Let's try this first example. So I have 3x squared equals 27. You see that x squared? I want to get that all by itself. Right now it's multiplying the 3. How do I get rid of the 3? Divide by 3. Whatever you do to one side, you do to the other side. That goes away. Then you have x squared equals negative 9. Yes? Now, I need to get rid of the square so that I can get x all by itself, right? To get get rid of this square, I need to square root. Whatever you do to one side, you do to the other side. But wait, we drew the square root. So we have to put plus or minus. So then those two cancel out. And then I have x equals plus or minus square root of negative 9. Guys, I have a negative inside the square root. What comes out? I. So plus or minus I root 9. But wait a minute, what's the square root of 9? 3. So x equals plus or minus 3i. Okay? Since this has an I in it, and there's a positive one, and there's a negative one, this has two imaginary solutions.
You'll still be wrong if you never put two minus.
The plus or minus?
Yeah, well,
Yeah, you will get a point taken off for that. Alright?
Is it always going to be in the set builder notation?
Yeah.
No, this is not set builder, it's just solution set. Yeah, and on the SOLs they do that, so that's why I want you guys to get used to seeing it now. Okay? Alright, so let's look at the next one. I want to get this guy all by itself, the x squared. What do I need to do about the 4? Yeah, divide it. When that goes away, then I have x squared equals 7. Yeah? How do I get rid of that square? Square root. Whatever you do to one side, you do to the other side. But I drew the square root, so I have to put what? Plus or minus. So then those cancel out. Then I have x equals plus or minus root or square root of 7. Guys, is 7 a prime number? Yeah, so I can't break that down. Do I need to take out an I? No, because it's not negative 7, so that's it. I'm done. Is there an I here? So then it's not imaginary. It's got to be real, right?
Solutions.
And how many?
1.
Oh, plus and a minus. So that's 2. Okay? You know what? Let's do this one. Yeah, let's do number, this is 3? 4? Okay. So I need to get the x squared term all by itself. What do I do to get rid of that negative 1/3?
Yeah, multiply.
Good. Multiply by the reciprocal. So we're going to multiply by negative 3. Yeah. Then those go away. And then we have x squared equals negative 120. Guys, I need to get to the x. What do I need to do to get rid of that square?
Square root.
Square root it. You drew the square root, so you have to put plus or minus.
Since it's negative, you have to have an I.
Good. So x equals plus or minus I root 120. Wait a minute, 120, that is a big number. I bet you we can simplify it. So off to the side, and put 120. 60 and 2?
30 and
30 and 2. And don't forget to bring down this 2, right? What about the 30?
15.
15 and 2. Don't forget to bring down these 2's, right? 5. 15 would be what? 5 and 3. So 5 times 3. Oops. For that guy. And then that one is 2. 2 and 2, right? So I have one group of 2's. Any other groups of 2 that are the same?
No.
Alright, so then that 2 comes out. What stays in?
5, 3, and 2.
5 times 3 times 2, which gives me
30.
30. So then basically this replaces this guy. So now I have plus or minus 2. What was already outside? I root 30 equals x. Okay? How is that? Well, weird, huh?
Yeah.
Alright. So this is it real or imaginary? Good. It's imaginary because there's an I. And how many? 2. Alright. Can we go to number 5, please? Or I think this is number 6. Is it 5? 6. Yeah, that's what first period told me. He said I got the numbers wrong. Alright. So whenever you get something like parentheses squared, that is the squared term that you want to get all by yourself, or all by itself. So what you're going to do is the same problem, right? You can't go into the parentheses to solve for this x until you get rid of that square. So to get rid of the square on the outside, we're just going to square root that whole thing, which you can do. Whatever you do to one side, you do to the other side. But when you draw the square root, you have to put what? Plus or minus. Yeah?
Yeah.
So then, this square root and that square, they cancel out. So then you're left with x minus 3 equals plus or minus, what's the square root of 64?
8.
8. But, guys, did I solve for x? No. X is over here. What do I need to do now?
Plus.
Add the 3. Add the 3. I'm going to show you something cool, though. If you ever add or subtract something to the other side, and there's already a plus or minus there, then this guy has to go in front of it. Okay? Don't put it to the back. It's got to go in front of it. So then now you have x equals 3 plus or minus 8. But hold on. Do I just leave it like that? It's all real numbers. You can combine them. Guys, this means you have 3 plus 8 and 3 minus 8. Huh? No. You're just solving it out. You're just simplifying. Yeah. What is 3 plus 8? 11. And what's 3 minus 8? Negative 5. So x equals negative 5 and 11. It is. So this is too real. Alright? Questions about this? Guys, if you stop here at 3 plus or minus 8, it's not right. Let's look at example 7. Hang in there, it's Friday. It'll be over soon. Alright, so guys, with this, do you see a parentheses squared or just an x squared? Parentheses squared. So that's the one that I want to get all by itself. So what do I need to move first? Oh, I need to get this all by itself. Subtract the 3. Now I still want to get this all by itself. So what do I need to move? I need to move this 2. Yeah. How do I move the 2? Divide. And when you divide this by 2, it doesn't do anything to the inside of the parentheses. All it does is just cancel those out, okay? So then we have x plus 5 inside the parentheses squared equals 3. Yes? Now what? Yeah. Whatever you do to one side, you do to the other side. And since you drew the square root, you got to put plus or minus. So then these 2 go away. Then you have x plus 5 equals plus or minus square root of 3. 3 is a prime number. I can't simplify that anymore, so I leave that. Right? But, is this equal to x right now? No. What do I need to do? Subtract the 5. Since there's already a plus or minus on that side, it has to go in front, right? So then this becomes x equals negative 5 plus or minus root 3. And you can't combine them because you can't, I don't want a decimal. Leave it as a radical. Are my solutions real or imaginary? Real. And how many? 2. Negative 5 plus the square root of 3 and negative 5 minus the square root of 3. Okay? All right. I know, you guys are doing a really good job. One more. So then, you know what? Then go back to the front. Look at this guy. Go back to the front, down at the bottom. You know what? You can solve this x squared equals 4 by factoring or by square roots.
Yeah.
By factoring, what do? You make it equal to 0, right? X squared minus 4 equals 0. What factoring method can you use here? Those. So then that's x plus 2, x minus 2, and then you have your mini equations, right? Tom, are you writing this down? So x equals negative 2 and x equals 2, right? And since they're the same number with different signs, I'm just going to put plus or minus 2. Yeah? But look at this. Solving by square roots, what we just did, right? It's already at x squared equals. So, how do I get rid of the square?
You square root it.
Square root it. All right, so square root that side, square root this side.
2 squares.
When you draw the square root, what do you have to put? Plus or minus. So then those 2 cancel out. And then you have x equals plus or minus the square root of 4. What's the square root of 4? 2. So x equals plus or minus 2. Isn't that the same thing? Yeah. I love this way if you don't have that bx term. All right. Questions?